The draft of a ship's hull is the vertical distance between the waterline and the bottom of the hull, with the thickness of the hull included. In the case of not being included, the draft outline would be obtained. Draft determines the minimum depth of water a ship or boat can safely navigate. The draft can also be used to determine the weight of the cargo on board by calculating the total displacement of water and then using Archimedes' principle. A table made by the shipyard shows the water displacement for each draft. The density of the water and the content of the ship's bunkers has to be taken into account. The closely related term trim is defined as the difference between the forward and aft drafts. Drafts of a ship. The draft aft is measured in the perpendicular of the stern. The draft forward is measured in the perpendicular of the bow. The mean draft is obtained by calculating from the averaging of the stern and bow drafts, with correction for water level variation and value of the position of F with respect to the average perpendicular. Variations of the draft. The draft of a ship can be affected by multiple factors, not considering the rise and fall of the ship by displacement, draft variation by list, draft variation by water level change, allowance of fresh water, draft variation by passage from fresh to sea water or vice versa, heat variation in navigating shallow waters. Draft scale. The drafts are measured with a banded scale from bow and to stern, and for some ships, the average perpendicular measurement is also used. The scale may use traditional English units or metric units. If the English system is used, the bottom of each marking is the draft in feet and markings are 6 inches high. In metric marking schemes, the bottom of each draft mark is the draft in decimeters and each mark is 1 decimeter high. The implications of draft. Large ships. Larger ships try to maintain an average water draft when they are light, in order to make a better sea crossing and reduce the effects of the wind. In order to achieve this, they use sailing ballasts to stabilize the ship following the unloading of cargo. The water draft of a large ship has little direct link with its stability. The latter depends solely on the respective positions of the metacenter of the hull and the center of gravity. It is also true, however, that a light ship has quite high stability, which can lead to implying too much rolling of the ship. A fully laden ship can have a strong or, on the contrary, a weak stability, depending upon the manner by which the ship is loaded. The draft of ships can be increased when the ship is in motion in shallow water, a phenomenon known as squat. Draft is a significant factor limiting navigable waterways, especially for large vessels. Of course, this includes many shallow coastal waters and reefs, but also some major shipping lanes. Panamax-class ships, the largest ships able to transit the Panama Canal, have a draft limit but are usually limited by beam, or sometimes length overall, for fitting into locks. However, in the much wider Suez Canal, the limiting factor for Suezmax ships is draft. Some supertankers are able to transit the Suez Canal when unladen or partially laden, but not when fully laden. Canals are not the only draft-limited shipping lanes. A Malacca-Max ship has the deepest draft able to transit the very busy but relatively shallow Strait of Malacca. There are only a few ships of this size. Pleasure boats. A small draft allows pleasure boats to navigate through shallower water. This makes it possible for these boats to access smaller ports, to travel along rivers and even to beach the boat. A large draft ensures a good level of stability in strong wind, as the center of gravity is lower. For example, ballasts placed very low in the keel of a boat such as a dragon boat with a draft of 1.20 meters for a length of 8.90 meters. A boat like a catamaran can mitigate the problem by retrieving good stability in a small draft, but the width of the boat increases. Submarines. For submarines, which can submerge to different depths at sea, a term called keel depth is used. specifying the current distance from the water surface to the bottom of the submarine's keel. It is used in navigation to avoid underwater obstacles and hitting the ocean bottom, and as a standard point on the submarine for depth measurements. Submarines usually also have a specified draught used while operating on the surface, for navigating in harbors and at docks.